Hello and welcome back to DevOps Fundamentals by SkillSpeed. In this video, we are going to talk about Vagrant and Docker. We will have a small comparison of these two very popular DevOps technologies. So first, we will have a small comparison of these two specific tools, namely Vagrant and Docker. And then we will have a generic comparison of containers versus virtual machines. So let's take a look at what are the similarities or differences between Vagrant and Docker. The first and the most important difference is that Vagrant works at hardware level virtualization, whereas Docker achieves OS level virtualization or operating system level virtualization. So what we mean by that is, in case of Vagrant, we are talking about the providers with the virtualization tools such as AWS EC2 instances or VMware Workstation or VirtualBox. All these are traditional virtualization tools which give you abstraction at the hardware level, whereas Docker gives you the abstraction at the operating system level. What it does is virtualizes your operating system kernel. So this is one of the very fundamental difference between these two technologies. The second difference, and probably the equally important difference, is that in case of Vagrant, it is not going to work alone. You need to have some kind of virtualization technology such as again AWS or Docker or VMware or VirtualBox, because it works as a wrapper around any one of these tools. So you need to have a provider before you can work with Vagrant. Vagrant standalone cannot do anything. Whereas Docker does not require any providers, because the Docker works on the OS kernel on which it is being installed. So if it is installed on Linux, it will virtualize the Linux kernel. If it is installed on Windows, it will virtualize the Windows kernel. Now, at the time of the recording of this video, we have Docker available for Windows platform as well. Again, specific versions only. More specific is Windows Server 2016. However, it is available. Maybe about a year back, Docker was available only for Linux. Vagrant gives you the multi-platform support. What we mean by that is once you have Vagrant installed on a single machine, and let's say that is a MacBook. You have installed Vagrant on a MacBook. MacBook is your base OS or maybe the host OS, you can say, but still you can have a guest machine, which is a Vagrant virtual machine which you're going to create. It can be a Linux machine, it can be a Windows machine, anything, whatever base box you have, it will translate that into a virtual machine. That is not possible in case of Docker. Now, as of now, we have two different examples of Docker, Docker on Linux and Docker on Windows. So if you have Docker on Linux, you can have only Linux containers. And if you have Docker on Windows, similarly, you can have only Windows containers. Another important thing to understand is Vagrant is platform independent. So what we mean by that again is that Vagrant you can go ahead and install on all the major flavors. It is available for you, Linux, Mac, and Windows, all of them. Whereas Docker is not available for all the platforms, at least not in a straightforward manner. We do have something called Docker Toolbox or Docker for Mac, but that's not exactly, technically speaking, that's not exactly Docker for Mac or for Windows. There is a level of abstraction which you need to understand. And essentially it is working on a virtual machine on which it gets installed. So technically the abstraction level of OS is happening only on Linux, even though it is running on Mac. So that is the reason we call it as platform dependent. Now let's take a look at more generic comparison, virtual machines versus containers. Again, this is one of the topics which is often confused. People think VMs and containers can be interchangeable. There are a lot of confusion around this and a lot of myths around these two technologies. There are a lot of people who kind of mingle these two. Some of the people think that containers are very lightweight virtual machines, which is not exactly the case. They are completely different virtualization technologies, as we have seen. So we'll have this comparison between the platform types. So one is virtual machine, and the other platform is containers. So the first criteria, or the first parameter on which we will compare, is the size. So virtual machines are pretty large due to hardware level virtualization, and when we are saying large, we are comparing that with containers, because when you talk about containers, it's very small due to OS level virtualization. So essentially what happens is, in case of virtual machines, we do have an actual bare metal server on which we are installing the operating system, and that is the reason we need the actual OS. So in case of virtual machines, you will find that the CentOS machine or a Red Hat machine, it's typically 3 GB or 4 GB space it needs just for the operating system to be installed. Whereas in case of containers, you have Docker images for CentOS and Ubuntu and all these standard Linux flavors, which are pretty small, which are like 100 MB or 200 MB or 300 MB at max, which is a huge difference if you compare that. How much time it takes to boot on each of these platforms. So since virtual machines are, apart from if you take out the fact of the hardware level virtualization, they behave in exactly the same way as a machine would. So that is the reason even the boot time is pretty similar to an actual machine. So anything between maybe 45 seconds to up to 5 minutes it will take, depending on what kind of flavor you have, what kind of OS you have, how many startup programs you have in your Windows or Linux machines and things like that. Whereas in case of containers, it's less than a second. The moment you run, for example, if you have worked on Docker, the moment you run Docker run command, it's not even a second when you get a new container created for you and up and running for you. Because at the backend, you are not running an actual container. I mean, you are not starting a new container. Rather, it's just a new process which has been spun up for you as a result of the Docker run command. Again, we'll talk about in detail about this when we cover Docker. But you can see the difference in how much time it takes to boot a virtual machine versus containers. The third criteria is the resource utilization, and once again, containers win here. If you talk about virtual machines, they take considerable resource overhead due to multiple virtual machines. So there is a considerable overhead of resource utilization. What we mean by that is, when you talk about virtual machines, they typically need a manager, for example, VirtualBox or VMware ESXi or any such other virtualization software. So that software itself needs resources to run, which is an extra overhead, which is not giving you any kind of productivity, but you still need that. That's a kind of necessity you have in your infrastructure. Whereas no such thing is required in case of containers. So it's almost nil resource overhead when you compare that with virtual machines. You do have it. It's not there. It's not the case that it's zero. It is there, but compared to virtual machines, it's very negligible. And this one is a very important parameter. What is a use case for each one of them? Because one important thing to understand, there is again a misconception in the IT industry, especially with the new folks, that with the invent of containers, now virtual machines are going to go away. That is not going to happen. Virtual machines are here to stay. At least for the next couple of years, nobody is going to touch virtual machines. They are here to stay, right? But yes, virtual machines has a different use case, and containers have a different use case. So when we talk about virtual machines, they are very good for traditional multi-app scenarios. So you have a database, you have a web server, you have an app server, and you want to run all of them in a kind of a cluster catering to your application. So that is the time virtual machines are a good option to be used. Whereas containers are very good when you have microservices architecture and you have small services and you want to scale up. You will have multiple instances of a single microservice. That's a very good use case for containers. So that was a small comparison of Vagrant versus Docker and then containers versus VMs. This is a very commonly confused topic, so that is the reason I wanted to make sure that you have a good understanding on this. Do let us know what you think. If you have any questions, please go ahead and raise a support ticket. Thank you for watching, and see you in the next video.